Hello all, welcome back. I hope you're all doing good, and I also hope that you guys enjoyed the videos in Angular. A few days back, when Professor asked the topics for guest lecture, some of your classmates had asked for database topic. So I'm here today with a lecture on database. Let's start our journey. Database is a very important component in any application. There is no application without a database. We can emphasize in such a manner. Uh, before the entry of NoSQL, the decision users has to make is just between MySQL or Oracle database to use. But after the entry of NoSQL, users had to make an additional decision whether to use a SQL database or a NoSQL database. Both have both has its own advantages and disadvantages. Uh, so each kind of databases are used for specific kind of applications. So let us start with the differences between them so that we can understand which database will be suitable for what kind of applications. SQL database follows a predefined schema. Yes, in SQL we have to define a predefined schema before we can start storing data. So this is so restrictive that you have to think about the schema before you can start storing any data. Whereas NoSQL have dynamic schema. You don't need to define a schema beforehand to start storing data in NoSQL. That's a lot of flexibility. So a lot of times we don't have any idea like what kind of data we'll be storing, and we might add more data later. So in those cases, NoSQL is a better option. SQL are standard table based. They have rows and columns, whereas NoSQL databases have different types, can be stored in different ways. Like it can be a document based database like MongoDB, uh, a key value pair database like Amazon DynamoDB, a graph based database um, like Neo4j and white column stores. So each of these types have advantages, and each one is suited for different kinds of applications. Uh, SQL based databases are vertically scalable, which means you increase the CPU memory in the same machine. Whereas in NoSQL databases, it is no NoSQL databases are horizontally scalable, which means instead of increasing the power or the capability of a single machine, you are adding multiple machines uh, to support scalability. Which means instead of storing the database in one machine, you are making a copy of it and storing in another machine, so that even when you're getting a lot of requests, we can just direct it based on the traffic to either one of the database copies that are available. SQL is by default meant for complex queries, which means you can give complex queries and execute it freely. But in NoSQL databases are not built with complex queries in mind, so they are not suitable when if you have to execute any complex query on it. SQL databases are suited for transactional type of applications. Example, ATM applications. So ATM applications uh, involve a lot of transactions. So SQL databases are the app fit for that. But NoSQL NoSQL databases are not suited for transactional type of databases because they are not asset compliant. Uh, a database which is not asset compliant cannot be used for transaction because we need those atomicity properties if something goes wrong in between a transaction. So even though we can use NoSQL databases for transactional type of applications, it is not recommended since the use case of transactional type of application is for SQL databases. Some of the example of SQL databases are MySQL, Oracle, Postgres, and some of the examples of NoSQL databases are MongoDB, Redis, RavenDB, Cassandra, HBase, and CouchDB. So as a verdict, if you're working with structured data, you know what you're going to store, or the data is very streamlined, or you're going to work with transaction type of data, then you can go for SQL. On the contrary, if you're using hierarchical data, or you don't know what kind of data uh, application you are building application in which the data keeps evolving, and you don't know a fixed schema for it. And in that case, in NoSQL databases gives you a lot of complexity. Then you have to go for NoSQL databases only. So you have to make the decision based on the data that is involved in your application, rather than just going by the pros and cons. MySQL. So I'm going to take one database of each type, and then I'm going to explain how to make a database connection, CRUD operations, and I'm also for SQL I'm also going to give a piece of advice of how to design a good relational schema. So as we know, like MySQL is owned by Oracle. It is very stable because it has been used for years, and it has a huge community support. There are a lot of database experts out there who have a wide knowledge about MySQL. So if you run into any problems, you will definitely find a solution immediately in case of MySQL. So that is one of the advantages of MySQL, using MySQL. And let's see. So I'm going to go through all these. These are the agenda of that I'm going to cover in MySQL. I'm going to show you how to make a database connection, how to perform CRUD operations, and how to design a good relational schema. So uh, I was thinking, like, since there are a lot of backend languages available, I couldn't accommodate all the languages. But I thought, while I was thinking which one would be the most used, I thought Node.js would be the most used database backend language by you guys, since it is really simple and it works very well with the JavaScript frontend. So I have chosen Node.js backend, and I have explained how to make a database connection and how to perform CRUD operations on that. So to make a database connection, a MySQL database connection from a Node.js backend, all you have to do is download and install MySQL module, and then import in your application. You have to create a connection object to MySQL server, and then you have to connect it. I will show the step-by-step code. First, to download and install MySQL module, all you need is Node Package Manager install in your machine, and then all you have to give is a single command npm install MySQL. Then you have to include it in your application by storing it inside a variable, so that you can use all the methods that are inside MySQL driver. And then once you have imported the MySQL module or included MySQL module in your application, all you have to do is create a database connection using create connection method, and then you have to provide some parameters like host, username, password that you have set for the database. And also, if you know if you have already created a database beforehand, then you can even send database parameter along with the along with the other three parameters. And then once you have created the connection object, you just need to call connection method on the connection object to connect to the MySQL server. Let's see the whole code and stuff so that you can get a good idea. All you have to do is once you have executed npm install MySQL, you just need to include it in the first line of your application, like require MySQL, the module name inside the variable, so it becomes so you can access the methods of those modules later. Then you have to create a connection. For all database applications from a backend, you need to create a database connection before you can connect to it. That database connection methods usually have the parameters like the host, the username, the password, all to connect. So we are using the MySQL module, and then we are using the create connection method of it, and then we are giving the parameters like host, user, password, and the database that you want to connect to. So you're storing this inside con variables, so which is a short form of connection. Then you can name it whatever you want, and then con next you have once you have stored all the parameters with your create connection object with all the parameters, then you can just call the connect method on it, and you can pass a callback function to it in case if you get any error with database connection. You can just get the parameter, and then you can just throw the error. If there is no error, then you will it will be logged in the console as connected. So it is always advised to log something in the console, like you need some indication whether you have made um, correct database connection, or whether you have connected to the database or not. Otherwise you might experience some errors later. So it's better to always have uh, some log commands over here, so that you get a good idea that whether it has connected or not. So we have covered how to make a database connection. Once we have made the database connection, then we can perform all the normal SQL queries that you want to perform. So this is the same thing like you are importing a MySQL. These are nothing has changed. So once you have created the connection object and you have connected to it, inside that, then all you need is you can store the whole query that you want to execute on the table inside on the database inside inside a variable. So I'm just this is the first command that create table, and then I've given the table name and the fields that are going to fields and the types. So and then the method that you're going to use to execute the query is the connection object and query method on connection object. So we first used connect to on the connection object. We have to observe that we are using on the connection object. Next one is like once you have connected, you have to execute a query on it. So even that it's a part of connection object only. So you can execute the query, and then you can just send the query inside it. And always it's good to have a callback function, so that you get a good idea of what is happening. Same way, if it gets success, then you will table created will be logged in your console, or otherwise the error will be thrown to your console. So this is how. So I have just shown one example. So you can just replace whatever command you want here. If you want to insert something, and you can just do like insert into and customize and all those. So whatever, and select and update, delete commands, everything you can give from here. So the syntax is same. All you have to do is change the query over here. This is all about CRUD operations. It's as simple as that. Next, designing a good relational schema. Before you can start, before you create a database, or you create a set of relations, or also called as tables inside a database, you definitely need to spend a lot of time thinking about the relational schema. A lot of big uh, I will call as beginners or novice programmers, they don't spend a lot of time on thinking about relational schema. They just uh, sit at the last minute, and then just they create they just create what they think that is right. That is not true. For database, you can even spend a lot of time thinking about the schema. You have to spend a lot of time thinking about the schema, so that it does not give any problems as the application scales. Uh, Often you may ask that this is not easy, that you might not see the problems that might come when the application becomes large. That's true, but to a certain extent, you just definitely have to think about the schema before you are proceeding with the database creation and the application. So there are when you have to create a good relational schema, then a word comes to your mind, which is normalization. So there are many normalization forms. I'm not covering all the normal forms over here. I'm just going with the best one, voice code normal form. Ultimately, every application which has a database is always advised to have a voice code database which is compliant to voice code normal form. Uh, so I will tell what is the aim of voice code normal form. The aim of voice code normal form is to not mix two super keys in it. It just you have to separate tables such that each table has only one super key, and there is no like two super keys inside a table. I will explain with an example to make it more clear. So we have a table, we have a relation which is like which is not a good design. You have a lot of fields over here. So first what you have to do is like this is a table which has fields like it's a class table which has course ID, title, department name, credits, section ID, semester, year, building, room number, capacity, time slot ID. So first what we have to do is we have to list all the functional dependencies that are available in this. Functional dependencies are nothing but the constraints that exist among the fields. So for example, with course ID, you can get the fields like title, department name, and credits. So you have to mention. So since you have a good idea of the data, you can just list out all the functional dependencies like that. Next, using building and room number, you can just get the capacity. For example, it's also null 405, room number 405. You know the capacity will be 50 or 60, something like that. And then course next functional dependency that is available is course ID, section ID, semester, year. So using course ID and section ID, semester, year, you can get the building, room number, and the time slot ID. For example, your course like com 4620 and this semester is spring, the section ID whatever any number, and then section semester is like spring, year 2020. You will get the building like Southwick 240 time slot, like whatever time slot it is. So these are the dependencies that exist among the fields. So first we need to list all the things, all the dependencies that are available. Then what we have to do is we have to divide the table in such a manner that only one super key exists in a table. For example, so we have divided class into three tables: course, classroom, and section. If you see the first table, course has it's nothing but this functional dependency has been converted into a single relation. So there is only one super key, which is course ID. If you have course ID, you can get all the title, department name, and credits out of it, the credits from it. So course ID is a primary key over here, and we are not mixing any other field over here. So based on the function, if you list all the functional dependencies, it's easy to convert it into a boys code normal form. Next, classroom. With classroom, you can just get, if you have the building number and room number, which are both it's a combined primary key, then you will get the capacity. Last one is a section. With course ID, section ID, semester, year, you get building, room number, and time slot ID. So here only this complex primary key is super key is available, and this is the primary key over here. So no other key is mixed, and hence each of this table serves its purpose. You can get the course details, you can get the classroom details, you can get the section details, and they are like related to each other using referential integrity, like using the primary key foreign key constraint. So course id will be stored as a foreign key over here, and it will be a primary key in this table. So you can just reference the prime if the foreign key course id can reference the primary key course id. And classroom as building and room number as primary key. Here you will be storing at foreign key. From here you can just get the detail of capacity. So what I'm meaning is, what I'm coming to say is like, if you want to see the updates in other tables, you can just for seeing the updates in other tables, because these are all separated, they are not related right now. How we are creating relation is through the primary key foreign key constraint. So since you're doing like that, then you can using this field, you can just get the details from that table about the title, department name, credits, because those fields are not there in this table. So this is the so whenever you are creating an application, always spend some time in designing your relational schema, thinking about the relational schema, what kind of data you are going to store, and then come up with the functional dependencies that might exist with your data, and then convert all of them into separate tables, such that only one super key available. If course ID, then only those fields should be there, and then create relationship between them using the primary key foreign key constraint. So this is a piece of advice that I wanted to give to all the developers that we have in this class. So we are done with the SQL database. Let's move on to NoSQL database. For NoSQL, I have taken MongoDB, since MongoDB is the most popular NoSQL database. So we have NoSQL databases, as I told earlier, have dynamic schema. They don't have a predefined schema like an SQL, and it is horizontally scalable. Um, SQL databases are vertically scalable, whereas NoSQL databases are horizontally scalable, which means you have the database running on multiple machines instead of just increasing the capacity of a single machine to perform better under high traffic conditions. So uh, also MongoDB supports cloud deployed database. So MongoDB has come up with something called MongoDB Atlas. It's a very useful feature which wherein MongoDB has deployed its database inside clusters. um, the cloud service is provided by there are three options that you can choose from, like Amazon Web Services, Microsoft Azure, or Google Cloud Platform. The choice is yours. So they are using those cloud platforms to deploy the databases in clusters. So even that is possible in MongoDB right now. So even here I'm going to cover two topics, which is how to make a database connection from a Node.js backend and how to perform CRUD operations on the database. These are the two topics that I'm going to cover in NoSQL database. So to make a database connection from a NoSQL from Node.js backend, all you have to, instead of MySQL module that you are downloading in when you downloaded, now you have to download MongoDB module, and you have to once you and then install it, then you have to create a cluster and a database in MongoDB Atlas, which I'll be showing, and then you have to connect to it. So MongoDB, downloading and installing MongoDB is achieved using this single command. If you have Node Package Manager already installed in your machine, so npm install MongoDB will download and install the MongoDB module, and then you have to in your application you can just include inside any variable or any constant so that you can use the methods that are available inside it. So you have to use require MongoDB, and you can give it as Mongo client or whatever you can name it. And then, so next part is you have to create a cluster and a database in MongoDB Atlas to access the database. I will show you a demo of how MongoDB Atlas is. So you can just go to mongodb.com/cloud/atlas, or you can just give a Google search it. The first link will be this one. As you can see, I told you, like, there will be three providers. Like, you can choose AWS or Google Cloud Platform or Azure, whatever you want. So I already have an account and I already have a cluster running in MongoDB Atlas. So I will show you that the cluster which is running. All you have to do is sign in. I have already created an account, and so everything is set up for me. If you want, you have to create an account with MongoDB. MongoDB gives free cluster for everyone, one free cluster. So I have made use of that for my application. Logged in now. Yes, this is the MongoDB Atlas platform. I already have a cluster all set up and running. So if you want to build a new cluster, you have to click a build a new cluster. But right now I don't think I have any free thing, so it's coming like 0.54 per hour. So this is like the number of options that you have. You can just select the cloud platform that you want to use. You can go with AWS, or you can go with GCP, or you can go with Azure, and you can choose the specific cloud center or data center. I Okay. Each of the cloud providers, they have the different centers, so you can choose whatever you want. I just went with the standard North Virginia one of Amazon AWS. So I'm not going to show you the process because I don't have the free cluster. I will not be able to create a free cluster anymore. So the process will be pretty much easy. It will be menu driven. Like, it will give all the details. Once you have chosen the platform on which you want to host your database, then you have to whitelist your IP address. Whitelist your IP address, and then you have to create your user credentials. You have to create a database inside the cluster, and then you have to create your user credentials, like the username and password that you want to enter. And once you have done all those things, you will get something like this. You will inside in the dashboard, you will get something like this is I've used for my application Roomies. So it is displayed here. Once everything is set up, you will see something like that. Once you click on connect, connect is a place where you will get the connection string for every to make a connection to a database. You definitely need a connection string in case of MongoDB. So once you have created the cluster, all you have to need is you have to click on connect. There are three options. You can connect using Mongo Shell, connect your application, or using MongoDB Compass. MongoDB Compass is a GUI-based database, GUI-based application where you can see all your databases and tables that you have inside your account. So right now I'm going to connect your application since we are going to access MongoDB from our application, and I've chosen the driver Node.js. You have different backend languages that you're using. Based on that, you can choose. I'm choosing the Node.js, and version 3.0 or later. So this is my connection string that I'll be using to connect to my MongoDB database. You have to just copy and then paste, and then you have to give the password over here. Let's go on to our slides. So that's about like creating a cluster and creating a database and setting up in MongoDB Atlas. So once you have done all those things, then you can connect your Mongo client to your MongoDB cluster and database. So these are the three steps that are needed for database connection. Now I will show the code that is needed. So as usual, first you need to include a MongoDB module inside any variable or constant that you will be using further in the function. And then I'm writing inside an asynchronous function so that it will execute in an asynchronous fashion. So const URI is the URI that I showed minutes before, where you can get from your MongoDB Atlas. You just need to copy and paste here, and then you have to change it. You have to change it by a corresponding username and password. By default, it gives the username and also your cluster name. You just need to key in the password. Just be careful while you're keying in the password, or do a hashed version of it, or provide it from any file that is not available to everyone. Because if you're like hosting it on GitHub or something like that, everyone will be able to see your password. So try to find a way of like storing it in a secretive manner instead of showing it to everyone. And then once you have then what you have to do is you have to use this module and then create a Mongo client with the connection URL by passing the connection URI. So that client will be stored in this variable, which you can use a client object further to connect. It is always advised to do all the database related operations inside a try catch block, because that will pinpoint the mistakes that is happening. If you're facing any issues, or if you're having any errors or exceptions, you can directly get it. You will get a good idea of what is happening instead of not doing it. It's always advisable to have it in a try catch block. And I've given await client.connect. Client is the object that is a connection object, and then I'm using the connect method on that. Await is a blocking operation. It means like await pause the execution until it is connected to the database. So always use await, because if you're not giving await, it might go to the next modules, which might not work without database connection. So give await. So and another thing is await can be used only inside an asynchronous function. So keep that in mind. And then you can give a catch block. You can print it in the console, and then finally you have to close the database, close the connection always. That is also await, because you have to wait until it is getting successfully executed. So this is the procedure to create a database connection from Node.js to MongoDB. And next let's go to CRUD operations. To perform CRUD operations, it is the same, like nothing has changed. The URI, the URL that you're copying from your Atlas, and then you're creating a client using the Mongo client from the module that you have imported. and then client dot connect. Once you have connected, you have to give the you should always give the URL, and then you can give the callback functions for it. Um, callback fun so inside the callback function has two cases. So it either has error or db. So when you're attempting to make a connection, if there's any error, all the details will be stored inside error object. Or if the connection succeeded, then all the details will be stored inside this data db object. So next we are just checking whether it's error or not, and then you are asserting it. If it's not, if there is no error, then you can log it. As I already told, it's always a good practice to log. And then so now let's go to the first. I'm going to show you the insert part. To insert, I'm using a MongoDB driver. So inside to insert, all you have to do is db dot. I am just referring to a table inside the database that I know. So db dot collection will get you the table. Like in terms of SQL, I'm telling you, collection is like the table in SQL. And then the method that you have to use is insert one. If you are inserting only one entry into it, you have to use insert one, and then you have to give whatever. Since this MongoDB uses bson form of JSON, so it is very useful. MongoDB is a go-to database to use with JavaScript backend like Node.js. So you are just giving a new entry with a value, a key a and value 1. So that will be stored. It's nothing like a column equivalent of SQL. And then always you are sending a callback function to see whether there are any errors occurred. If any error has occurred, it will stop the execution here. It will show you some error here. And if there is no error, then you can just check whether you have inserted one. You're asserting it here. And the method to insert more than one entries is insert many. So as you can see, then you have to enter the entries inside a array, since there are more than one entry. And then you have to pass the callback function where you can check whether the operation succeeded or the operation failed. So here you can check, you can access the properties of like R is the success object. So you can just get properties like inserted count. So if it's inserted count is 2, since you're storing 2 values, so it should be 2. So if it's true, then it is success. So you can then always close your database once you have done with all the functionalities. So for this demo purpose, I have just nested two methods inside it. As you can see, like insert one, insert many is there. Like once you insert one entry, I'm inserting 2 more entries inside it. If you want, you can write it separately also. It is just my preference. And then next one I'm going to do is like the update command. So the same thing, like client and connection. Once I get connected to it, then I'm, instead of last time the difference is nothing, but you might see difference. Like last time I didn't get it into a different variable. I just access from DB, and then inside that collection, inside the table collection, which you can access using collection, and then inside. Now I have just stored the table inside a variable db.collection, the table or relation name inside my database, and then I'm performing the operations on it, like update one. The first entry is like which entry I have to update, and then I have to change it to set using $set, and then the new entry, new bson entry that I have to do. So once this is done, it's always this is the usual stuff where you send a callback function, and you have to, you're checking whether everything goes as per the plan. So, and then the next one is called at update many. Update many is like updating many fields at the same time. A equal to 2 or something. So you're updating that, and then you are setting and you are changing it to b1, b equal to 1. So since you might wonder, like there is only one field and you are telling update many, because there are 2 entries of a is equal to 2 in that. So we are doing that. Now we can check that. After doing that, if it's error, we can it will come here assert. It will assert here, and if there is no error, then assert dot equal r dot match count or modified count. So there are 2 entries you can see here, and db dot close. So for I'll reiterate, for insert you will use insert one, insert many, and for update you use update one, update many. As you can see, only the operation name is changing over there. And for delete, same thing. You are just getting the table, and then you are using delete one, and then you are giving the entry what you want to delete, a1. And once deleted, you can just access a property like deleted count, and you are checking whether deleted count is 1. You're checking whether you have deleted only one entry. Deleted many, since the a equal to 2, there are 2 entries of it, you just give a is equal to 2, and then you're checking whether deleted count is 2. Same way like that. And then this is also delete one, delete many. So only the update thing is only the operation name is changing, but the one and many thing is same. And the next one is like finding or selecting. For this, I'm first inserting like 3 columns of the same, both the 3 are the same things, or a1, a equal to 1, a equal to 1, a equal to 1. And then I'm checking whether there is there any error, or is there any if it succeeded or not. And once inserted, so instead of select in SQL, all we have to use is find. And what I'm doing is I've inserted three documents. Instead of I forgot to tell you, like each of the entry will be called documents in MongoDB. So I'm just going to, instead of getting all the three documents, I'm going to get 2 documents. How is that? So on the table, I'm executing find method, which is nothing but a select query. And inside that, I'm giving the value like a equal to 1, and to search it. And then I'm limiting it to 2. This is the function that I am like chaining on it. Like limit only 2 means only I need only 2 documents. Even though there are 3 results, you just give me 2 documents. And then you are changing it to an array, because there will be two values of it. So you're converting it to an array, and then you can just check. Then you are storing it as docs. So the result of the execution will be docs. So docs.length is 2, because you are getting two database entries in an array. So you can check like that. So it's so easy in MongoDB, right? Like instead of typing a big command select, you're just using a JavaScript like functions like insert many and find. And there are a lot of functionalities that you can append on it, like limit. It is so flexible, and you can do a lot of things on it. Instead of just manually just pulling all the data, you can just limit it. You can convert it into array, delete. All these commands are, instead of a big command, you just have just one update, one function that does everything, and you just need to pass the parameters just like a uh, normal JavaScript function. So this is MongoDB is one way of doing connecting to MongoDB. Also, there is another module called Mongoose. So whatever you feel comfortable, I personally prefer MongoDB, because MongoDB is faster. I've tried it with Mongoose also, but MongoDB is faster because it is a default module for connecting to a MongoDB database from Node.js. And this is not all about this is not everything about MongoDB module. There are a lot of functions, useful functions, that are used inside that are used in MongoDB module. Since this is a short lecture and I couldn't cover every function that is available in it, I didn't do it. I will be posting a link in the description, which is nothing but the documentation of the MongoDB Node.js module. Just go through the module so that you can know how powerful it is and what are the functionalities that you can use out of this module. So this is all about MongoDB and database connection CRUD operations on MongoDB from Node.js. Thank you, everyone. It's been a great journey of database technologies today. Please feel free to comment, and stay safe. Stay home. Stay safe. See you next week with another Angular lecture. Bye, guys.